Welcome to the Explainer. Today we're taking a high-speed road trip, but we are absolutely not getting in a car. We're actually going to travel through the invisible, heavily engineered physical infrastructure of the internet. It's really easy to think of cyberspace as this magical, wireless thing just floating around in the air. But the reality, it's a massive, tangible system made of millions of miles of cables, countless routers, and colossal data centers. It's a question we almost never pause to ask. What really happens when you click a link? You tap your screen and boom, a video plays, right? But in that literal fraction of a second, you've essentially fired a starting pistol. Clicking that link triggers a massive global relay race. Your request gets chopped up into these tiny units of data called packets, and those packets are about to cross oceans, navigate some insanely complex digital intersections, and bounce off edge servers. We're going to decode that exact journey right now.
So here's our literal travel itinerary for this explainer. We're looking at 1. How the data journey begins. 2. Navigating ISPs and IXPs. 3. The need for CDNs. 4. Inside the data center. 5. Decoding cloud service models. And finally 6. The shared responsibility matrix.
All right, part 1, the data journey begins. Think of your personal device and your local network as the driveway of the internet. Before you can hit the massive digital interstate, you got to get out of your own house first.
Let's actually trace this path step by step. It all kicks off at step 1, your endpoint device. So your phone, laptop, smart TV, whatever. From there, your little data packet moves outward to step 2, the access network. Now this might be your home Wi-Fi router or maybe the nearest 5G mobile tower. Then, for step 3, it hits your local ISP, your internet service provider, which routes it through an IXP, or Internet Exchange Point. Step 4 merges us onto the high-capacity backbone network. We're talking massive fiber optic cables that span entire countries and literally cross oceans. Finally, step 5 lands us at our destination, either a local CDN edge server or a massive cloud data center. This is the exact physical route your data takes every single time.
Moving to part 2, navigating ISPs and IXPs. Our data packet has officially left your local driveway and it's now hitting the local and regional roads managed by those internet service providers and internet exchange points.
Your ISP is essentially the local road system connecting you to the wider world. They provide the basic routing and connectivity. But, it's definitely not a flawless system. ISPs have their own vulnerabilities. They can suffer from major routing errors, unexpected outages, or they might even implement DNS filtering. And the path your data takes isn't totally fixed either. Routing decisions can change from millisecond to millisecond. In fact, 2 packets sent in the exact same second might take entirely different geographical routes to reach the exact same destination if a sudden outage happens somewhere on the network.
Now, to prevent massive global traffic jams, the internet relies heavily on IXPs, or Internet Exchange Points. These are actual physical buildings where large networks come together to exchange their traffic. You can really think of them as massive, high-speed highway intersections. Imagine if every local network had to have a direct, individual wire connecting to every other network on Earth. It would be impossibly chaotic. Instead, they all just meet up at these IXPs to hand off data packets super efficiently.
Part 3, the need for CDNs. Okay, so what happens when the final destination is just too far away? Say you're sitting in London, but the server hosting the video you want is all the way in Sydney, Australia. Even traveling at the literal speed of light through fiber optics, that sheer distance creates a delay. And we need speed.
The big takeaway here is that we really don't want data to travel across the globe if it doesn't absolutely have to. Enter the CDN, or Content Delivery Network. A CDN is a network that caches or temporarily stores copies of content physically closer to the users. They act like local distribution hubs. If a huge new viral video drops, the CDN keeps a local copy on an edge server right in your city. That way, your data packet only travels a few miles down the road to fetch the video, rather than crossing an entire ocean. It gives us incredible speed and absorbs those massive spikes in internet traffic.
Part 4, inside the data center. So, if the data isn't cached nearby in a local CDN, we finally arrive at the end of our road trip. We've reached the massive, highly secure physical facilities where the computing actually happens, the data center.
It wasn't that long ago when, if an organization wanted to host a service, they had to build a traditional on-premise data center. They had to buy and maintain all the hardware, pay the exorbitant electricity bills for cooling, and hire physical security guards. But today, we rely on the cloud, and the cloud is simply renting scalable computing resources remotely. Make no mistake, these are still very real, massive physical data centers. You just don't have to own the building or the server racks yourself. The cloud gives us rapid deployment and practically infinite scalability without any of the physical headache.
Section 5. Decoding cloud service models. Now that we're renting all this space in the cloud, we really need to talk about how we rent it. We're going to slow the pacing down just a bit here because we need to carefully unpack these acronyms that completely define modern cloud computing.
Broadly speaking, there are three main ways we consume the cloud. First up is IaaS, or Infrastructure as a Service. Here, the provider gives you the physical servers, the storage, and the networking. You, the customer, control everything else: your operating systems, applications, data, firewalls. It's basically like renting bare metal virtual machines. Next is PaaS, or Platform as a Service. Here, the provider steps up to handle the operating system and the runtime environment as well. You just bring your application code and your data. It's fantastic for developers who just want to build a managed web app. Finally, we have SaaS, or Software as a Service. The provider handles everything: the infrastructure, the platform, the application itself. All you really control are your user accounts and data settings. Think of your webmail or an online CRM. Notice how the balance of control heavily shifts from the provider over to the customer as you move from IaaS to PaaS and then to SaaS.
And finally, Part 6, the Shared Responsibility Matrix. This shift in control brings us to our final and honestly perhaps most critical concept of the explainer. Security in the cloud is absolutely not a one-way street. It's a partnership, and it's governed by the Shared Responsibility Matrix.
The golden rule of the cloud is basically this. The provider secures the cloud infrastructure, but the customer must still configure identities, networks, data, applications, and access controls properly. A huge misconception is that moving to the cloud just magically means the provider handles all your security. That is simply not true. Think of it exactly like renting an apartment. The landlord, the cloud provider, is responsible for securing the building, maintaining the locks on the main entrance, and making sure the roof doesn't leak. But you, the tenant, you are totally responsible for locking your own front door, keeping track of your keys, and, not leaving the stove on. So regardless of whether you're using IaaS, PaaS, or SaaS, there are always certain things that customers are responsible for securing. You are always on the hook for identity and user accounts, meaning making sure you're using strong passwords and multi-factor authentication. You're responsible for data settings and sharing, so if you put a highly private document in a public cloud bucket, well, that's on you. You have to manage application access policies, determining exactly who gets to see what, and you must maintain safe configuration practices across the board. The cloud is incredibly powerful, but a misconfigured cloud is literally a fast track to a massive data breach.
So let's bring this all together. Every single time you open an app or click a link, you are triggering this incredible global relay race in a matter of milliseconds. You are relying on a massive, highly physical chain of infrastructure, from your local Wi-Fi to the ISP, zipping through those IXPs, across transoceanic backbones, into local CDNs, and finally arriving into the humming server racks of a cloud data center. And the security of that entire journey? It relies on a delicate, fragile matrix of shared responsibility.
It's honestly an absolute marvel of human engineering, but it is deeply, deeply interdependent, which leaves us with a final thought to ponder as we wrap up today. With such a massive, potentially vulnerable chain of shared infrastructure carrying almost every aspect of our digital lives, how resilient are we really when a single link breaks? I hope this explainer gave you a newfound appreciation for the invisible, physical world buzzing right beneath our fingertips. Keep questioning how things work, and we'll see you next time.